Hello everybody, I'm very happy to be with you today, and we will see together how fast is it to create a simulation application using geospatial data with Unreal Engine. So we will start creating a new project from scratch and select the game category. Nothing very special there, we can start with a blank project. In this case, I will use C++ because I'm working with early version of some plugins that need to be compiled, but as soon as the next version of Unreal will be released, it will not be needed anymore. So let's call this project simulation and run the wizard to create everything for you. So I already set up a small folder containing what I want, and I just open my project. In my folder, I have some additional content, a model of a 3D terrain, and the future georeferencing plugin. So I go to content, I copy content to my project, and same for the georeferencing plugin. And for that, I just need to create a plugin folder and paste it there. Once it's done, I just need to open again a simulation project. It will ask me for rebuilding this plugin. I still need to build it because I'm working with an early version of this plugin, but it will be part of 4.27, so this operation will not be needed anymore. Next step is to replace this old sky model with a new sky atmosphere system. So we will start by making some cleanups and keeping on the scene only the floor and the player start. We will remove everything, and now we will have two actors. First being the sun sky system. When you put it on your sky, you need to wait a little bit for the exposure to adjust. You have a consistent sky system which is there. You still notice a black color in the bottom of the screen. It's because you don't have any geometry there. Normally you would add mountain or terrain. If you don't want to have this black color, you just need to add an exponential 8 fog to your database. And that's all. But we will adjust some settings. First, I want the skylight not to be at the 75,000 lux, but more 120 lux, which is more physically accurate for sun. If I do that and go to the sun sky actor, I can change my time of day, and now my sun is moving in the light. If I go exactly to 18 hours and look at the sun, it's very strange. It's because we have too much indirect scattering. For that, we need to cancel the scattering behavior of the fog that comes in on top of the one from the sky atmosphere. So just to do that, you need to go to sun directional in scattering color and put it to 0. And you can also play with the helix fall off to write 2, which is, or 1 if you just want to have a nice horizon effect. And now we can go back to our sun sky and check other time day. And for instance, if I go to 20, it's dark, but if I wait a little bit, it will become clearer. If I wait for the auto exposure, yeah. And it should be a dark night. It's not normal. It's too clear at night. We need to fix our exposure to have something more realistic. So, in order to do that, we need to add a post-process volume to the scene, and this will be our main post-process volume. So we need to check the infinite extend, and once it's done, we can go to the exposure settings. Just to fix it, we can raise very high the exposure speed in order to have something very reactive. We can change it back afterwards. And now if I go to 20, you see you have this exposure really fast. And just to limit our adaptation to have something dark during night, we go to this post-processed and set up a minimum exposure. And you can test different values, but what I like, the one I like is 6. I mean, it's night. You can see a little bit the atmosphere, but it's still dark. So we can just add a moon to the scene. We will start by adding a directional light to it, and we call it moon. And the right lux value for moon is roughly 3 lux, which is not a bad value. And in order the moon to be able to drive the sun sky atmosphere, we need to check 2 values. First one is the atmosphere sunlight, means you check it to say that this light will be driving the atmosphere, and we need to change the light index to tell it's a second light for our sun sky system. And now if I take the moon and try to edit its rotation with Control L, it doesn't work because the Control L shortcut is only meant for the sun. And what we can do to edit that, if of course we can drive the moon by a nice system, which is not possible yet, but the nice trick is to put the sky at nice location, let's say this, take the directional light, copy its rotation, go to the moon, past the rotation, and you will have your moon at the same location as the sky. And so if you move the sky farther, the moon will be there and will be there at night. And even at dawn, sorry, you can mix both celestial bodies in your scene. So it's not that bad. So we just select this actor, I'm sorry, create a folder that I will call env for environment and put everything in. And since I'm happy with my level, oh, see, I need to make one thing related to the moon is to tag it as movable. Otherwise, you will have the lighting needs to be rebuilt message. So we are done, and we save this current level as our startup level. I will create a new folder for levels and call it outdoor. So basically, we are done with our nice lighting system. Let's start by adding real terrain in our level. So I will go to the mesh. I just imported it before, and I did to the level and go backwards to check how it is imported. It's a random mesh of a random country, and I will go very high and put my level start right there by snapping it to the view. So we will start with this view. And now it's time to define our georeferencing system. I just find an actor in the placed actor mode, and just by dropping this actor in your level, you will be able to define your georeferencing system in Unreal. In that case, the terrain is made in a projected mode, so in a flat planet context. And I remember when I created it, I was using the UTM zone number 31. So the APSG code for that guy is 31. And I also remember that my coordinates were coordinate of my origin in UTM coordinate were these coordinates. And that's all. Once I do that, I have the right georeferencing for my geometry. So to prove it, I will add a status bar showing our actual coordinates. So I will go to level blueprint and add, create a new widget. Create widget of class UMG GeoStatusBar. It's a widget provided with a plugin that draw coordinates on the status bar. I don't want to create player, but just to get my player controller. I take it and add my widget to the viewport. And that's all. I can compile, hit play, And here we go, we see our actual coordinates in georeferenced mode. If I try to move, it's very slow. We really need to add a new pawn and new game mode to have faster motion in our level. Okay, so I will go to the content, create a new folder. Let's call it blueprints. In this blueprint, I will create my own game mode, which will be BP simulation game mode, and my custom pawn, which will be inheriting from a pawn, but I will take the default pawn, the base class, and call it BP simulation pawn. I edit this pawn, go to the motion movement components, and I'm able to save it. And now in a world setting, I can tell that I want to use my simulation game mode along with my simulation pawn. Last thing I forgot to set up is the sun sky. We have put the coordinate for the terrain, but currently the sun sky system is not depending on the georeferencing system. So in order to be consistent, we will have to put there the actual coordinate for your origin. So I also know by converting UTM coordinates to latitude longitude coordinate that this guy will be at this latitude longitude. We are in GMT +1, and see we need an offset of minus 80 coordinate just to have the sun sky north direction. It's not very visible there, but you have the north direction pointing there in the north of the country. That's all. We will notice that there is something strange now. It's because of our exponential 8 fog. Now that we have brought terrain, it's not needed anymore. The fog will be ended by the sun sky system, and now when we are close to the ground, we have a nice looking sky system. We can press on play, and now we can move very quickly. And if you want also to be sure about some location in your environment, you can run this editor utility widget, and it will display your actual viewport location in all the projected or geographic coordinate system you defined previously, along with the information about the point under your mouse coordinates in real time. And that's only in the editor, but if you just want to display some actual geographic coordinate when you are at runtime, you can drop a location probe somewhere in your scene, and this probe will display a widget with the actual coordinates at which the origin of this probe is located. So we just worked on a flat terrain, which was crafted previously, but it's time to switch to another mode where we can use geospatial data streaming modes. So let's say that now I want to bring geospatial data from Cesium using 3D tiles in my Unreal projects. I had an early cut of their version, which is called Cesium Unreal. Once again, I need to build it, so I copy it in my project folder. And once it's done, I can go to reopen my new project solution, double click on it. So when you start your project with the Cesium plugin enabled, you have access to a new Cesium window where you can directly connect to your account as Cesium Ion. So we have one at Epic, so I will just log in. And we start with a startup page that enable us to add the default content, and I will I will start by adding a world terrain with Bing aerial imagery. But we can also add any kind of asset which is available in our Cesium Ion account. So in that case, I will add to the level photogrammetry asset of Melbourne. That's all. And now we can go to the Cesium georeference actor, which enable us to define where is located our Unreal origin in latitude, longitude. So I will switch to Melbourne coordinates. And as you can see, anytime I change that, the Cesium dataset is refreshed and I'm right around the location of Melbourne. And even in the editor, I add the data streamed in. So we need to be consistent in our Unreal georeferencing system for the status bar. So we switch to run planets, and in that case, we know that we are in WGS 84 georeference system, and we don't express the origin in projected coordinate system, but also in latitude, longitude. So I will enter the same values there. And once again, same for the sun sky. We need to be consistent and enter the same values there. Melbourne is in GMT plus 11, and here we go. We are our dataset ready to be played in the engine. And I start there because my player start, of course, was at the wrong location. So I will go back and snap it to Melbourne. Player start, snap object to view, and we can check that the sun is working. So I will change the lighting condition, and then we can play and have the terrain streamed once again. Here we go. And we can see that if I move, and I can move very fast and very far away, at one point, now of course I can go up and down. I'm lost in the sea. Pacific Ocean is quite huge. Yes, that's what I wanted to illustrate. If you go far from the origin, you will end up with a non-horizontal horizon. It's because you are in, I would say, a geocentric coordinate system. We need to have a pawn that adjusts to your globe shape. And Cesium provides such a pawn, and we bring the sun to a better time of day. And instead of my simulation pawn, I will create a new pawn, but which is inheriting for globe aware default pawn. This pawn is provided by Cesium, and I will call it BP Cesium pawn and change my world setting to use this BP Cesium pawn. And once again, I need to adjust his motion and drop some bunch of zeros there. There we go. Save and play again. And in that case, I can see that if I go to the other part of Australia, I have my horizon, which is always aligned to my camera. Yeah, that's just I wanted to illustrate that. And once again, same for the provider, we are in full round Earth mode with the streaming of geospatial data right away. And as usual, since you are in an Unreal application, you can have access to all the interactivity tools of Unreal. That's all I wanted to show today. So thanks for your attention. Bye.